Hi everyone. In this videos, I am going to talk about 1D peak finding. Now, what is 1D peak finding? Let's suppose that we have an array. The number of elements of array is 9, and the value is a to I, and a to I are numbers. And we say position 2, which is B, is a peak if and only if B is larger or equal to A and B is larger than or equal to C. Likewise, we say C, which is position 9, is a peak if and only if it is larger or equal to H. Okay, this is an H case because this position in the last index. The problem we are going to tackle is finding a peak if it exists. Okay? Now, what is the most straightforward algorithm you can come up with? The one you come up with is maybe look for an element from left to the right. So you look at the position 1 and compare to the element index at 2. And if you find a peak, it's over, right? We successfully return the peak. Otherwise, we look for the element at position 2 and compare to the next value, which is the element position at 3, right? Because previously we found that the index of position 2 is larger than or equal to 1. We just compare the element index at 3. Okay? Now, let's look at this example. Now, I create this function called naive1d, which takes input an array. Okay? Now, the input I define here is called array, and the number of element of array is, I guess, 1 2 3 4 5 6 7. Yeah, 7. So those 7 elements, we are going to look for a peak. Now I'm going to explain this function a little bit. So for each index in this array, if the index is 0, which is this value, right, first element, because this is H case, we are just going to compare the elements next to it. So for the first case, we are compare 0 to 1. Okay, so this is this if statement. Okay, if index 0 and if array index is larger or equal to index plus 1, we found a peak. Okay, but since this case 0 is less than 1, this if statement returns false. Okay, so we will not find a peak. Now next if statement is edge case, especially the last element. If the index is the last element, last index, we just compare to the elements last to the second. In this case, it's 4. Okay? And if the index is neither in the first index nor the last index, we compare the value in the last index and the index plus 1 position. Okay, so let's say, so like I said, 0 is less than 1, so this for loop go to next element, which is 1, right? Since 1 is neither index in 0 nor last index, we are enter this else statement, okay? And then we are going to compare this 1 to array of index minus 1, which is 0 in this case, right? So we compare 1 to 0. Oh, 1 is larger than or equal to 0. Okay, and then go to the next statement. Array index is larger than or array index plus 1, which is we compare 1 to the 2. But in this case, 1 is less than 2. So this statement is false. So we are going to the next value or index. In this case, 3. 3 is no edge case. So again, we are enter this else statement and we compare the value at previous position. So in this case 2, we compare 3 to the 2, and 3 is larger than 2. In this case, we compare 3 to the 5, but 3 is less than 5, so this is not a peak. And then again, this fourth statement look for this index value, which is 5. 5 is position in the middle, right? It's neither in the first element nor in the last element. So again, we are going to enter this else statement and we compare 5 to the previous position, which is 3, and 5 is larger than 3, so this statement is true. And then we compare 5 to the next value position, which is 4. Obviously 5 is larger than 4, so this statement is true. Thus we return this 5. This is a peak. If there is no peak, we return none value. Okay? Let's execute this function. Like I said, this function returns a 5, which is indexed at 0, 1, 2, 3, 4, 5. Yes. And now the important concept in the algorithm and data structure is complexity. There are mainly two complexity. The one is running time complexity and the other is space complexity. Now, in this video, I am going to talk about running time complexity. Now, what is running time complexity in this algorithm or function? Like I said, this is a very straightforward algorithm that we look for every element. And what is the worst case scenario here? Worst case scenario is that we may find a peak in the last index, while we may not have a peak at the end of the day, right? How many false statements is computed in these cases? We are going to compute a for loop for every element of this array. And in computer science, usually people denote the number of array or input size n. Okay, even though in this case number of array is 7, but we call it as n, okay, to just generalize to other array. Okay, so what is the worst case complexity? Like I mentioned, worst case complexity is when we have a peak in the last index, or when we don't have a peak. So how many times this for loop is executed? N times, right? In this case, 7 times, sorry. So in this case, we say worst case complexity is order n. I wrote this here theta of n, but just think of this order of n. Now, do you think there is any efficient way of algorithm? What I mean by that is that if there are any algorithm that compute or find a peak in much more faster time, I'm going to talk about that algorithm in the next video. Thank you.